Hello and welcome to another tutorial. So this time we are going to be making some functional lifts or elevators and we are going to be getting those set up in a way so that we can very easily add in other floors, things like that. And so that's the key stuff we're going to be making. So let's dive right on in. Now, starting wise with this, I'm starting out with, I've already got my existing first person character controller in here. So there's already stuff there for that. I've also added in things like Pro Builder. That's what I used for building up the segments here for the lift. So how I've designed the segments for lift, we've got the actual lift itself. So it's a separate piece with two separate doors and that on it. And then each level, if we take a look at an individual level, I can move that around. You can see this is what comprises a level, which a level houses the lift shaft, and it has a set of exterior doors here. So the idea being that if I wanted another level, that all I would need to do is, say, duplicate this and move it up, and I could snap it like that, and then just rename this for neatness. Then I've immediately got another level. So that's what we're wanting to be able to achieve with this. So I haven't set up any of the code for it yet. We're going to be building up the code for this from scratch. And so there's a few different things there that we need to have happening with this. We obviously need to have stuff like the doors opening, but we obviously don't want the doors just opening when there's no lift there. So we need to have that being locked to when there's a lift at a location. We need to have the lift moving between levels. We might want to, have it then that we can have some controls over how quickly it moves, stuff like that. So let's start to get the pieces that we need for this set up. And I'm going to begin with getting set up a folder for my scripts. So there's a few different things, and I'm going to split this up into sort of three areas. One is going to be the lift itself, so the actual housing of the lift. That's going to have the user interface in it for selecting a level. That's going to be able to be controlling the doors within that as well. So that's going to be what the lift is controlling. Then there is going to be a level script, and that's going to handle the doors, the exterior doors. It's going to handle a call button. And then there's finally going to be a lift controller that's going to manage moving the lift between different locations. So let's get those scripts set up to begin with. So lift, and then we'll have our lift controller. So lift controller, and then we will also have a lift floor. So just splitting the functionality based upon the different areas. Now in terms of where I attach the stuff, so the lift shaft doesn't have the actual exterior door in it. That's currently part of the corridor there, but we do have this lift exit. That is the one that actually has the particular chunk of the exit there. So if I go to the lift exit, so that is its own prefab. So the lift exit is where I'm going to attach that lift floor script to. So it's going to then be able to animate these doors. So I'm going to set up a folder for animations, because I need to give my lift here an animation control, an animator. So it gets an animator. Then I create an animator controller. So this is going to be anim controller lift exit. So we can link that up to this, and then we can start to set up the animations for it. So we're going to bring up our animation window, and we'll just record these animations. So first thing I want to do is, we'll call this lift exit, and we'll call this close idle. Close idle, not going to be really needing to be doing much. What we can add in, just for the sake of this, is the position for each of the doors. Not strictly, we'd be able to likely get away without it, but I just tend to do this force of habit. If there was further changes I wanted to make to this, be easy enough to do. So that's the close idle. Then I'm going to create a new one that is lift exit. And this is open idle. So in this case, we again add in for our two doors their positions. Now the difference in this case is going to be that we want those positions to be a little bit different. So we can see our X position, and what we want to do is get a sense of for those doors where those need to be. So the left door, it's X, probably goes to, I'm going to say 2.25. Let's check how that, actually 2.225 looks pretty good. So I'm going to say position X 2.225. Make sure we update both of the values there for that. So that's good. Then we add in the one for the right side door. So again, right side door, transform position. Now this will almost certainly end up being minus 2.225. In both cases, minus 2.225. So that's good. Then I set up my animation for opening. So lift exit, open, and that's going to, we'll take our, in this case, this is where I could do a record. So I can take my left, just update that initially so that it changes, and then we change that so that can stay like that. Do the same with the right one. We need to just make a slight change, so it adds in the key. Then we're going to put it at 30. We'll add in the next sample. Actually, no, we can do it at 60. It's fine. So at this point, I go to minus 2.225 for the right one. Set left, we go to 2.225. So that's good. So we can just go back and hit play. That speed's pretty good. I'm happy with that. And then I can actually copy those most likely and create a new clip, lift, exit, close, .anim, paste those in, but the values will be reversed. So that will be 2.225 minus 2.225. Then we go to the end, 0.75 minus 0.75. So we just have closing. So it's good. So we've got our animations there for the door setup. We can edit our animation controller because it should by default go into close idle. And then the sort of sequence we want it to go, we want to transition to open. That will go to open idle. So we just set up all of our transitions. Make our graph look a little bit neater. We do want to set up not a new layer, we do want a parameter. So we want a trigger for open, and we'll also set up a trigger for close. So the opening one ties into that. Closing ties into close. Now with these, we don't need there to be any exit time, and because of the idle ones, there doesn't need to be any transition there. It can just immediately switch. Same thing here. Fixed duration, that can stay. Doesn't have an exit time. Set that like that. So that's cool. We've got the animation controller set up for the lift exit. So that's pretty good. Now these will also need criteria then potentially for the doors opening and closing. So that means it's going to kind of need a trigger to be able to say whether it should actually open or not. So I'm going to add in a trigger onto this. So what we'll set up is we'll give it a box collider, and we'll mark that as a trigger. Size-wise, want that to be the size, probably a little bit larger than the size of the doors. Maybe 3.5 is about right. And again, a little bit wider, just so that there's enough space there that it'll start opening when we're a bit of a distance away, and give it a little bit more height too. So that looks pretty good. That should cover for activating the door. We could make that so that's covering sort of the full height there. That's pretty good. So, okay, we've got our lift exit configured. We are going to need a couple of other bits of animation. So the lift exit's got its code on it. It's going to be talking to the animation controller. It's going to be getting things like collision events, stuff like that. So we can set up a couple of things for it. Void on trigger enter, and a void on trigger exit. We want it to require that animator component. So require component type of animator. That just makes it that we can really easily refer to that. Linked animator means in our wake, we can retrieve that. So it'll make it easy when we need to open, close the doors. We'll be able to talk to that. Lift floor is also going to need an ID. So serialize field, string, display name. So this will be something that will be shown to the user. And I want to then set up, make that listed like that. So I'll have a public string display name that just links to it. It just allows me to keep your private variables private and they can't be modified. So I'll be able to set the names of each of these levels. That just gives us something then that we can actually display for the user when we're putting up a panel of things. So that's going to be level 1. The advantage with this also is it means we could have these named anything. So if you want to actually have a larger gap between levels, things like that, you easily could. So all of the lift exits have got all of that set up. They'll be able to kick off the things they need to, which is good. The other thing that we kind of need for our lift exits is we do also need a call button. So we're going to set that up in the prefabs as well. So in our lift exit, so I'm going to add in, so this will be a world space UI. So we'll start by, we just add in a panel. Once we've got that, we change this to world space. It does have a graphics raycaster. Now, the usual stuff I always do with world space UI, set the width and height to be about what I want, and then adjust the scaling. So in this case, I want it to be largely square, and 0.01, so that's still way too big. By 10, so you can see sort of the size of that. That looks pretty decent. So probably, what's a good height for this? That looks a little bit low. Let's put that up around 1.5. I think is pretty good. Maybe a little higher, plus 0.25. Get everything nicely positioned. So that goes a little bit into that, so we'll put that at minus 0.3. So in terms of what this has, so call panel, we are going to add in a button. So we'll add in 2 buttons. They'll effectively do exactly the same thing. We could make them do different stuff at a later point if we wanted. But for now, we're going to just have them do the same thing. We'll add in a vertical layout group for this, because we do want it to force expand these, take up the full space. Give it a little bit of padding. And a little bit of spacing between those, I think will be good. Up button. And down button. So the idea will be, these will be how we actually can call the lift. And we'll just make that background darker. So change the text of both of these. Now that text at the moment is quite small. That's fairly normal. Often need to up the size of these, especially when I'm doing world space UI and then I've really scaled things down. So that's all right. We can just really boost up the size of that. So there we go. We've got our 2 buttons. We do want to make sure we link those to our lift floor. So we'll have a public void on call lift for up and public void on call lift for down. Now, as I said, at this stage, these are going. We're not planning on having these do different things. If we had multiple lifts, we absolutely could start to look at having some more sophisticated controls there for this. That's something that we don't really need at this stage, so we're not going to overcomplicate it. So we'll link these up though, but we're setting it up so we've got support for that in the future if we need, which is good. And that's a big part of it, is making sure we've got that support there. So walk on lift for down, so that's good. We've got those connected up. We want to also have it that it only, when it something enters, that it's only looking for particular tags. So string supported tags, which will make that player supported tag. The reason being is that we really don't want every single thing being able to access this. We really only want the player being the one that activates it. So we'll just make sure we've got the player properly tagged, which we do. Then we do want to keep track of a list of things that are in the area, just because we may end up needing that. Game object. So this is openers, for want of a better. Sometimes it's hard to come up with good names for lists like of this, but openers works. So if other compare tag to supported tag, then openers, we add that. Otherwise, we will remove it. So we do openers remove. It just means we're keeping track of whether there's something there. Then we need to be able to know if the lift is at this level. So for now, what I am going to do is set this up as a public, actually I'll set it as a serialized field. All lift present, because what we want to do is F lift present and openers dot count is greater than 0. Then we want to do linked animator, set trigger, open. Otherwise, then what we would do is we would set the trigger for closed. Set trigger, close. Now that would mean that we were, doing that opening a lot. So we really don't want to be doing that. So we want to keep track of, have we sent an open request? So I'm going to open sent. It's false. Bool. Close sent. Now, because it starts as closed, I'm going to say that close sent does start as true. So if that's the case, then if we haven't sent open, then we do this, and we set open sent to true. We also set close sent to false, so that we don't accidentally send it multiple times. It's probably going to be fine actually with the trigger. Let's see if it breaks without doing this. I reckon it'll probably be fine. That's checking if there's, so that one is fine for doing that. I think we can also actually just have this, that what we're doing is, yeah, I think this is actually a better way of doing it. It means we're checking stuff in a few more places, but I think that's okay. So if lift is present, then we do this. And what we can do is at that point where we go and change if the lift is present, then we can update this. So if lift is present, then we do that. Otherwise, well, in this case, we would set it to closed regardless, I think is safe. So that should mean our lift door there is functional as far as opening and closing when there is actually a lift present, which at the moment there obviously isn't, but what we want to test is that we can walk up to it, and at the moment nothing should happen. So I wander over here, nothing happens. Then if I change this so it thinks there is a lift present, and I walk up, then they open. They do close immediately. That is because if I go to the animations, lift close should not loop, and lift open should also not loop. So you do need to make sure those do not loop. So now I'm going to set that so that it thinks there is a lift present. And then we wander over, opens, closes, and open again. So that's good. I've got that side of it going. So now we need to start having some communication happening with this lift controller. And we need to actually have a lift controller. So let's start getting some stuff set up. So we'll bring in our lift, and the lift controller I think can validly go on the same object. Could kind of go anywhere. I might actually make it that it does go on its own separate thing. Just because if we did have multiple, I mean, it would be kind of potentially mayhem inducing of having multiple lifts in the one shaft, but we kind of could. So let's start setting up some stuff for what the lift controller is doing. So the lift controller, if we go to it, well, it's going to need to know its lift. So lift, linked, lift. It's also going to need a list lift floors. It's going to need that. So we'll get those populated because those are two bits that are pretty essential because we need to start having a bunch of communications happening between things. So we link up the lift floors. We can grab each one of these, drag those in. So now we've got all of our lift floors. So we can start to have some communications being able to happen there with this, which is great. So first thing that needs to happen is, well, lift floors also need to be able to talk to their controller. So this is where there is a little bit of sort of to and fro that we need. I'm also then going to give the lift floors a link to the controller. Linked controller. I'll rename that as well. So the reason being is the these, I want them to be able to go linked controller, call lift for up, and we provide it ourselves. Do call lift for down. And so those are two functions we're going to need here. So public void call lift for up, lift floor, requested floor. And we'll do the same thing for public void call lift for down. So I might just change this so it's call lift call is up. That way then it's just the one function. It's not really going to be needing to do stuff that's that different to warrant really having separate functions for it. So call lift true and false. So, okay, we've got that. That'll be able to do the calling of the lift. We need to make sure we've linked all of these up to our lift controller, just so that they can find it. So what we want to do is we want that is lifted floor thing to start actually being populated by the existing sort of setup there. So we want to control where that lift is originally starting at. So on the actual lift itself, I'm going to have it set what the initial floor is. So I'm going to have a serialized field. It's going to need the controller, linked controller, because it has UI that will be talking to the lift controller as well. And lift floor, starting floor. So it just means we've got all of the bits of information that we might need there and available. So we are going to start it at this particular floor. So we'll link it to that. We'll link it to the controller. So now I've got all the pieces linked together. Because one of the things then we need to be able to do now is position the lift. And that's something where the floors tell us that position. So if we take a look at where, and I'll just create an empty parent so you can easily, actually no, not an empty, yep. So we can see that's sort of the position currently for the lift. So we need to be able to be changing its height. So we're going to assume the X and Z have been set correctly, but the Y value is what we want to be able to change. So that's something where for the Y value, we want to ideally hope that it's able to just use the Y value of lift exit sort of setup here. We do have the lift shaft, which is going to be at a particular location as well, but the exit is kind of the ideal one where we want to be able to position the lift. So what we're going to do is very first thing the controller is going to need to do is position the lift. So our lift is going to have lift floor, and we need to be able to access its starting floor. So this is something where we need to be able to set up for accessing this starting floor. This is why I do often use underscores for these. Does make it a little bit easier when you're needing to retrieve them. I could just make the stuff public, but I generally prefer not to. So, okay, we need to get the starting floor position. So we're going to get our linked left. We are going to get its starting floor. And in terms of the movement, actually, yeah, we can probably just have the lift do it itself. So rest of the movement the controller could do, but I reckon, yes, this could just actually use this approach. So what I would do is I want to be able to ask the starting floor and then the floor Y or target Y. That I think is a good term for it. So we want to be able to go and set transform.position. And we want to be setting that to be a new vector3 transform position.x. We keep the x and the z, but the y is what we change. So then the lift floors, I want to be able to have here public float target y. I'm going to set up so we have a transform lift target, just so we can easily position this where we need it to be. So this will be lift target dot position dot y. This will make it easy for us to have this as something that's able to be sort of completely separate. So, because we can see where the lift currently is, and what I'm going to do, it's a little bit of a roundabout way of doing this, but it'll guarantee that I get the exact right Y position. So I create an object under it, bring that up so it's outside of it. And then what I'm going to do, so scaling things like if that are gone, which is good. So I add this into the lift exit like that. I link that up as the transform. And then I can update the prefab based upon that. So that's something where if I go, now it might add it into, we want to update the lift exit so we can apply all. And that should mean that in all of these, we go to the prefab. So it hasn't actually done it, so it has gotten confused about where to add that in, unfortunately. And so that's a little disappointing that it hasn't quite linked it up the right way. It has gone and correctly associated the right thing, but hasn't put it into the exit part of the prefab. It's actually put it into this one, which is not really what we wanted to have happen. So it should be able to undo that. So the apply all hasn't been applied there now. So unfortunately, it does mean I have to manually do this, but I can see the Y target is at 0.285. So what I can do is delete that, open the prefab, add this in at that same spot, and then link it up. It is just unfortunately something that we have to watch for with prefabs. It doesn't always apply them the way that we would want it to. So we can confirm the lift targets are correctly set up. So what that should mean is that wherever I position this lift, if I position it intentionally at a wrong spot, then well, actually intentionally position it way, way, way below, and I set the starting floor, that lift should now be correctly positioned. So we can check, and we can see it hasn't. And if we take a look, so it hasn't properly got the lift target. So if we revert that, so an issue with the applying of the prefabs, no exceptions this time. And if we take a look at where the lift is, that looks like it's positioned correctly. I can double check by making it so that it thinks a lift is present, and I can open the doors. You can see, yep. So, okay, we've got Y positions there now for it. We've got UI set up, so that's good. So now we need to know if a lift is present at a particular floor. So the lift itself is probably going to be the best way of actually asking that. So you can have lift floor, that won't be a serialized field, it will be a public lift floor, current floor, which we can do like that. Can also have a bool is moving. Again, we'll default it to not moving. So in this case, we can say current floor is starting floor. So then a lift floor, we can say a lift is present. So public bool, lift present, F, linked controller, lift. So we'll say this can actually give back lift, active lift. So we can access our active lift current floor if that is equal to this. Now we get rid of then R1 here. So now it'll just be an automatic thing that if it's present, so now what should happen is if I walk up to it, those doors should just open. Now we could also wire this up to the button being pressed. So you can see the doors have opened, which is good. If I changed it so the lift now starts on a different level, so we start it on level 2, then when I walk up to these doors, that lift should not open. So we'll walk up to them and they don't open because the lift is not there, because the lift got positioned at the other level. So that's good. We know if the lift is present now. We have now got a lot of the bits that we need, so we can start doing this controller. So we've requested the floor, and we'll ignore the is up one at the moment. Well, firstly, we need to check if requested floor is different to the current floor. So if it's different to active lift current floor, then we actually will need to do stuff. So what we might do is if it's the same, we just do return. Already at this floor, so there's not anything extra that we need to be doing. Then what we're going to do is we're going to need to tell the lift to move. So first thing we'll be doing is linked lift. We want to be able to say move to requested floor. We also, if the lift is already in motion, we want to, so we're really designing this for a single player thing. We're not going to go full on in terms of lift control logic. So if it's already moving, we'll do nothing. Actually, no, if it's already moving, we'll let it override it, which can just have it overwrite the requests, I think is fine. So that will have a public void move to lift floor, target floor. We want to have a lift speed. Float lift speed. We might make it time per floor. Could also be the thing. So time per floor. We might say takes 5 seconds of travel. So, okay. We need to... Actually, no, distance I think is a better one. Lift speed. We might make it that it's 2. So, okay, we've got the target floor. So first thing we want to do is moving goes to true. We want to keep track of our target floor. Floor, target floor. Then we can go, yep, target floor is that. So then in update, if we're moving, then we can do a transform, and the position is going to be a vector3 move towards. We can work out our target location. So vector3 target location, transform dot position, where target location y is target floor dot target y. So we move from our transform position to our target location by lift speed by time dot delta time. So that's going to move us there. Then we can check and see, okay, well, if vector3 dot distance between transform dot position and target location, if that's pretty much 0, that's less than the float epsilon, and is moving is false. Current floor is going to be equal to our target floor, and target floor is null. So have we arrived? It's moving. Then we can also, with that if we need to, because we do want the doors to be able to know. So this is something where we can then go, hey, current floor on lift arrived. That's going to be a useful thing for it to know. It's public void on lift arrived. So, okay, that's good. The lift, that should mean the lift, when we go and call it, that it can actually move. So let's find out. I'm going to move the game window down here because I want to be able to see at any point in time where the lift is. So let's head over. And so for being able to interact with these, you'll notice at the moment I can't. When we're working with World Space UI and all, there's typically going to be a little bit of extra bits we need to set up with that. So one of the things, because we saw the UI's not triggering there, that's kind of an expected thing when we are working with sort of a setup like this. We actually need to do a little bit to redirect the input because we've got the cursor hidden and locked and so forth. So what I actually need to do is I'm going to go to the character controller here, and there's a couple of things this is going to need to do. So we're going to have a using Unity Engine event systems. We are then in the input handling, So we have, the other inputs here. We are not currently picking up. There is support for the on fire input, and that's the one we're going to be using. So what we will do is up here, around the jump works, public void on fire input value. So if value, keep it basic, that's greater than 0.5 f, then what we need to do is we need to construct a pointer event data with, we give it the current event system, we set the position to the input mouse position. Then we are going to keep it fairly basic and perform the raycast. So we get a list of raycast result. And then we do an event system, current, raycast all, pointer data, and our results. And then we send through those events. So this is a very, very, very basic version. If we were doing more sophisticated things, we would need to structure this a little bit better. This is a super basic version of it. The video where I was doing some stuff for relaying user input, that is the sort of the more full-on version of how we can approach doing this. So we loop through all of these, and we can set a range that we want this stuff to actually activate for. So if result dot distance is less than config max UI distance, or max interaction distance we might call it, interaction distance, which we'll set that up in a moment. Then we do execute events, execute, hit result, or result.gameObject. We give it the pointer data, and we tell it the particular event that it is actually executing, which in this case is a pointer click handler. So there's a little bit involved for doing this, but it does mean that we do get the UI events coming through there. So we can go to our config, and we can add in that UI option. So we'll add in UI, public float, and I'm going to make it 2 meters to begin with, so I want it to be a reasonable distance. I want it to have a fair range, and just make sure that we're getting the events. We just want to check that. So let's fire this up, and we just want to check that we're able to be, we should be receiving the events in the console. It's the main thing that we're looking for. So we need to make sure we're reading the position from the right thing. So because we are using the new input system, we can't use ones from the old one. So what we can do is we can do mouse current position read value, and that will allow us to access the mouse position there. So that should mean that we can call the lift, and then when the lift arrives, we can check. So we've got our actual lift logic here. So when the lift arrives, that tells the floor that it's arrived. So we now know that a lift is present. So we could be checking if openers count is greater than 0. Then we could be telling it to open. So that's good. We probably also want to actually be telling the lift itself that it can open. So we might start with these and making a few changes in a little bit. But let's have this. We want to hopefully wander up to the lift, run it, and see that it has been called and the door opens. So over here, we hit down. Lift, we can see it arriving behind the scenes, and the door opens, which is cool. So we need to make sure both sets of doors open. So what I'm going to do is, well, when the lift has arrived, it can open its doors as well then. So we're going to set this up as public void open doors and a public void close doors. So this is also going to have an animator. So it's going to work in largely the exact same way as the lift floor one does. We use the same logic. The main difference is that the opening and the closing, I'm going to have it that the actual floor itself controls that. So we'll have a animator, linked animator. So when it arrives, I'm going to make it say this. Probably doesn't need that, but we can have it do that. So lift, carrot lift, or active lift. And then, so if that's the case, can then do active lift, open doors. So that'll make those open, that's good. We also need to, be able to keep track of, actually, we probably can just use active lift. We can just do that, we don't need to pass it through unnecessarily. We'll let it, just in case there is extra stuff we want to do. What that means is then when we go to open the doors here, we'll do the same thing. Open doors. And then here, we will do close doors. Also means we want to have a public void on lift departed. And we'll say that we pass through the lift again as well. And this should do the closing logic. So we want to make sure if we have departed a particular floor that we do that. What that's going to mean is that when we start moving, because we do have the logic in the lift for telling it that it's starting to move. So when we start moving, we would say current floor on lift departed. So that's good. So it should mean we can arrive, doors and things like that will be able to open, and both sets of doors will be able to open. Then what we want to hopefully see is we need to set up those animations for the actual lift itself, because we gave animations for the other bits, but we didn't set up the animations for the lift. So we're going to set up its animations. Now it's going to can probably use the same animations because the names are the same, but it'll need a different animator controller potentially. Because actually, no, it might need different animations because the animator controller is going on a different. No, actually, I reckon that'll work. Yeah, the name, so it's down to the naming. I think the naming is right. Just in case, I will give it a separate one. Have a feeling it might just work though, because those animations, pretty sure, can easily find out we switch to something like open. Okay, so it does need different ones because the positioning of those is different. So that's fine. That was something we kind of expected we would need to do, and that's okay. So we'll just make sure we've got that animator. We will get rid of those, and we will set up new animations for it. So we'll have our lift, close idle, just add in our two doors. Now I could have potentially just animated one of the positions, but this allows us to have the lift doors do slightly different things to the exterior doors, which I think is useful to have. It's good to have that support. So that's the close idle. We will create the open idle. That, again, we add in our positions. Now, we do know what these will be, 2.225 minus 2.225. So we do already know what these are going to be based upon the other ones, which is handy. So it doesn't take long to actually set these up, and it's good to make sure we've got the ones set up properly. We don't want to have them set up so that they're not correct. So we get our transform position for each one, and we'll do the same thing for the right door. And then we'll be pretty much there. There's not too much we need to then set up at this point afterwards. Minus 2.225. Grab those, set up our lift close. And we just reverse these around. And we can just play it, make sure that looks correct, which it does. We do want to make sure we set the ones that shouldn't loop off of being looped. So we turn off looping on those. And then on the animator, entry does go to close idle. Just set up our transitions. So we've got those there. We just need to set up then the criteria, so linking to the different triggers, removing the exit times from the idles so it can just immediately switch. So for close, no exit time. So that's good. That should mean we have our doors ready to go. We need to make sure now that animator, for the lift, we will just make that we link it up down in awake like we do with the other ones. So void awake, linked animator. So what I'm expecting to be able to do now is call the lift, head into the lift, because the doors, both sets of doors should open. And so I'm going to switch this. So I'm back in the main view here now because we've got enough stuff up and running that we can see this. So we move over, we are going to call the lift, has been called. Both sets of doors open. Now we did get R1s there looping. So it did go and close again. So that's something where we want to try and get a sense of why that might be happening, because that's something that generally should not be seeing that happen. So if we take a look at our lift floor, and easiest thing is if we set a breakpoint for where it's trying to do any of the closing. And we go back to this. So we move away. It should close. That makes sense. We move closer, opens. So you can see it's not getting activated by code. So that's where what we want to do is take a look at our lift exit. And we can, if we do bring our game view back down, can watch and see what happens. We'll stop this debugging because we don't want to interrupt it. So move away, go over here, runs. We need to make sure we've got that lift exit selected. So we can see it's in close idle. So we move over and it's immediately going because close is activated. And so it's not clearing the trigger. So that's something where we do often with the animations need to make sure we remember and linked animator, reset trigger. So when we go to close it, we're going to reset the open trigger. And when we open it, we're going to reset the close trigger so that it's not going and redoing it. So do the same thing here, where when we go set, we do a reset of the corresponding opposite one afterwards. So that should then mean we run over towards it. So it's in close idle, which is good. We call the lift. Should have arrived. We walk over, doors open. We can walk in, the doors close. Now those inner doors will not have closed yet. That's okay. They do properly open. So we can see when we set this up, we did actually get the setup here opposite. What was supposed to happen was these ones. It's so easy to miss. The ones that should have no transition time are the ones leaving the idles, so the ones that have the conditions on them. That's why it was actually having that issue. So now we'll be able to go, the lift doors will properly close, which is cool. So if they go, call the lift, fairly close to use the buttons, call the lift, should arrive, can wander in, doors close. So we've got the doors opening and closing. The final bit that we need is just a little panel inside to actually show the different floors. So inside every section of the lift, or inside the lift itself, we actually want to have a little bit of UI. So if we go over to the lift itself, we're going to set up UI. So it'll be a panel, buttons, floors, we'll call it. Again, this is going to be a world space 1. Again, we zero out the positions, we set the height, set our scale, and we're going to need to move this a little bit. It's about 200 wide by 800 high. Divide that height again. So that scaling is looking better. That's looking pretty good. So floors. I'm going to position this over here so that it's pretty much right up against the wall there. That's probably a pretty good spot. Yeah, that looks pretty good. That's at an okay spot. That was actually moving, unfortunately, the panel. So that's something you do want to watch for. Make sure you're moving the canvas, not the panel. Just wondering why the locations were quite out of whack. So there we go. That's better. Minus 1.95. It's pretty good. Height of 1.5. Might go 0.25 higher. The X position might go minus 1.7. Minus 2. 0.875. About the middle. I think width-wise, that needs to be a little wider as well. So there we go. So then we want to work out, okay, what do we want the buttons and that in this to look like? So set up a button. And with that, what we want to do is that panel we can see is actually around the wrong way. So that's all right. We can very easily flip our canvas. We want the button so that it takes up the full space. So that can be 0, 0, its pivot, 1. That. Its height, I think we go to probably even more than that. 100 feels about right. The text for that, again, similar to the other ones, we're going to need to make that a lot larger. And then we just want to test setting up our vertical layout group because we want to have these nicely organized. We do want to expand width. We're not going to expand height. Set up our bits of padding. And we just check. Okay, we can add in extra ones and it works out fine. So these, we then need to give them a little bit of script logic as well. So this is going to have lift UI floor button, because these do need a little bit of logic, because these are going to become a prefab that we can instantiate. So we'll set that up. This script have a public void on pressed. It's going to need to have a link to the lift controller. Lift controller. It's going to need to be able to access that button. So we'll have a serialized field text mesh pro UGUI button text. And we'll have a public bind. That's going to say link floor. We'll give it the lift controller. Linked controller. Floor name. So it'll set button text to that. We'll have a lift floor, linked floor. So we're just going to set up each of these. So those are linked because then when we press this, we'll go, hey, linked controller, and send lift to, and we'll just be able to say the linked floor. So that's going to be a function we have here. Public void send lift to the lift floor. linked floor. If that's the same as the one it's already at, then we'll do nothing. So it's going to be pretty much identical to that in every way, really. It's the requested floor. We don't have the up thing passing through, but otherwise it's identical for it. So that's good. The lift UI button will be able to send that through, can populate the text. We still need to populate the UI for it, but we've got enough info there that we can set up the prefab and everything for this, and that's the main thing. So we've got that. When we click, we run our script here. That is going to run the onPressed one. So then that becomes our prefab. That will be lift UI. So then we're going to need some logic for populating that lift UI. So that can go into our main lift script. So it's going to need to be able to populate that UI. We will have a transform lift UI root and a transform, not a transform, it'll be a game object, lift UI button prefab. So what I want to then be able to do is essentially for each var floor in linked controller dot floors, and then I want to be able to say I want to instantiate that prefab. So I want to instantiate lift UI button prefab at lift UI root. So lift UI game object. Well, I'll retrieve the script from it. So UI game object, because I know it will have that lift UI floor button. Because then I can say, tell that to bind to the particular floor, the linked controller, and the floor's display name, because we've got that accessible. So floor display name. So this should set up the floor UI. And the only thing I should need to do is set up this floors array here and make that accessible, which we've already got the floors array. So I should be able to just go list lift floor, floors, link that through, and then all going well, I just need to link up the prefab, and this will be able to add in all of those buttons. And I can update the prefab for that now that that's in there. So let's test this out. What I'm expecting to be able to do is, so it didn't set the prefab, got lost in the process, unfortunately. So we will link that up. Properly named. Cool. So now we run this. So I'm going to call the lift. Would mean the lift is on its way, which it is. You can see all of the floors. I'm going to tell it to head to floor 5. Now we're bouncing around a bit because that movement is currently happening inside update. So we will make a change to where that movement is happening. We should be on our way to level 5. We've stopped moving. But you can see it's not letting us out of the lift. We can take a look and see. We should expect the lift floor. We want to check that it's properly picking up that we're entering the area here. We can see that lift floor hasn't. What we want to do is check in the scene where the lift is. So the lift is in the right spot, which is good. If we check our exit here though, that lift doesn't have the colliders. So in this case, it's an easy one. We haven't updated the prefabs. So we'll go and update the prefab for the lift floor. So if we go to the prefab for it, so this is probably going to be, again, another one where I'm going to copy that component. I'm going to open the prefab and then paste that component in. And then go back just so that that's something where it likely would not be adding it properly. The other thing I want to do is the lift's movement. I want to change where that is happening. At the moment, it happens in update. That is something that I could, for example, move to a late update. The other thing I'm going to very, very quickly do so I can tell where I'm looking is set up a super, super simple little bit of UI for the player that gives me a reticle. So I'm going to add in just a UI image. You can see that there. I want to remove the raycaster. And just for good measure, turn that off of being a raycast target. I can select a sprite, give it a bit of transparency, and drop the size of it. Just gives me a little reticle, makes it easy to know what I'm actually aiming at. So, can test this out now. We do want to check that exception that is coming from something internal to Unity. So we can run over, call the lift, can get rid of our breakpoints and leave this to run. Call the lift, can hop in. Let's go to level 5. So it does still move around with late update, so we'll slightly change that again. This is a version of the character control that's not super optimized for moving on large areas. We're still moving, we're ticking along. And then we've arrived, doors open, and if I kamikaze off, we were at the top floor, which is great. So final change I will make to sort this is that's going to go to fixed update. And in the character motor, I'm not going to try and print, let's forget my key codes. So character motor has a few places where it is accessing transform.position. Those are just going to go to character rb.position. Because that will work a lot better. Cool. So, final test. We should be able to call our lift, head to a floor. Hopefully we're looking for smooth movement when we are in that lift as well. So we run it, lift will arrive, doors open. Let's pick a floor, let's go to floor 5. You can see smooth movement. I can move around here. Getting close to this, it's not going to cause any issues at the moment. And once I arrive, the doors will open. I'm up the top. I could then head down to, if I go to level 4, so to get a little bit more movement, that's going to be because this one doesn't auto anchor. So that would be another thing that we could be doing is anchoring the player controller to the lift. That's going to mean that it handles the movement a lot better. There are going to be some more updates I do to the character controller, but that is something where auto-anchoring it would be a big thing there that would sort of help out. But we've got our functional lift. We could be adding in extra displays, some cool stuff of what's happening when the lift is moving, things like that. We could be adding in various sound triggers, areas like that. But the main thing is we've got the lift logic all set up. We can add and remove levels, and our lift will just work. We just link them up to the controller and it will just do what we need it to. We could set up different lift shafts that access different things. The spacing, the gap that you have between them could be whatever you want it to be. You could have little sort of secret things where it's like you have a huge gap between the lift floors. You could have hidden stuff in between, and they would be able to be doing that quite easily. With the way that it's set up, the lift does physically move in the actual lift shaft. If I set this up and I move, so we've got a overhead view and then run this, we'll be able to actually see the lift moving. So it initially positions, then I call the lift, we see it move down. So this would be something where you could also intentionally have it that there is enough space there to be hopping on top of the lift, or having to avoid it, jumping between lifts. You could easily have two lifts parallel to each other with this setup. That's going to be able to be handled really easily. It's just a matter of cloning the objects. You can adjust the speed, everything like of that for the movement there of the lift. Thanks, folks. I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. Really helps out, really appreciated. If you got questions, chuck in a comment below. The full code is available up on GitHub. I've put the link to that in the description below. You can use this code for any of your own projects. Commercial, non-commercial, you're free to be using it. And if you have found the videos helpful and are really looking for a way to support the channel, then I do have a Patreon available, and there is a link to that in the description below as well. But until next time, bye.